So here I've got the results of some testing that I did earlier today, where I've got several processors and I did various tests using some test code. So if you have a quick look at the code. So I've got test pin 2, which is a digital pin, which I'm switching on or off. I've got the scope connected to that. So that's where I'm testing the speed out. It's an output to test the speed, the execution time of my code here. And then sensor pin is A0. It was the analog input used on all the processors. So in the setup, pin mode test pin was an output, and by default I'm setting it low. Now I was editing out, commenting out part of this code as I went along to start off with, and then taking out comments so that more of this code was being executed each time, so that I could see how long these reads and calculations and stuff was taking. So by default I was just setting the output high and then low again. All this bit was commented out. Then I'd tell it to do the analogRead as well. Then I'd tell it to do an integer calculation, and then I'll tell it to do these two floating point calculations. One which does a simple floating point calculation, and the second one which does a sine and a square root as well. And then turn that output pin low again. So let's have a look at the results. So at the top here I started off looking at times in microseconds, but it ended up being more useful to have the data in speed, as in kilohertz. So under revision 3, with only totaling the pins, I got 148 kilohertz out of it. Once I did an analog read, its speed dropped to 8.9 kilohertz. Adding maths in didn't make a difference to the speed. And then the Uno revision 4, which is a faster processor, ran at 700 kilohertz if only doing an I/O flip-flop. Adding an analog read slowed it down to 44 kilohertz, and the integer maths had no effect on the speed, but adding floating point maths slowed it down to 41 kilohertz. Then on the Dewey, got 160 kilohertz with only I/O being turned on and off. Analog read slowed it down to 95 kilohertz. An integer calculation had no effect on the speed, but adding floating point maths slowed it down to 26 kilohertz. The Mega ran at 87 kilohertz with just I/O. Adding an analog read slowed it down to 8.3 kilohertz, and no change when adding maths. The Teensy, with just I/O being switched, runs at 10 megahertz if just doing I/O. Adding an analog read slowed it down to 59 kilohertz. And integer maths didn't change that. Adding floating point maths slowed it down to 58.8 kilohertz. The Nano produced the same results as the revision 3 because they're the same processor. So it's 148 kilohertz for I/O, 8.9 kilohertz for analog read, and then the maths was the same, 8.9 kilohertz. And then the MKR 1010, just I/O on and off, was 292 kilohertz. Analog read slowed it right down because the analog was set to its longest sample time, so it was 1.2 kilohertz. Integer maths didn't make a change to the speed, and adding floating point maths slowed it down further to 1.15 kilohertz on the cycle time. So these are speeds for our processors, and it's an interesting comparison that's been done here on all the different processors in terms of speed. So the fastest when it came to analog reads was the Dewey, the 95 kilohertz. The fastest when it came to I/O was the Teensy at 10 megahertz. The Uno and the Nano were the slowest, of course. The revision 4, which is quite a big upgrade from the revision 3, produced generally higher speeds, because you know that that's running much faster and it's a different architecture on that processor. It's a 32-bit. So comparing those two from a revision 3 to a revision 4, those are fairly big upgrades in speed, which is why the revision 4 has been a very nice development for makers, because these are useful speeds. And then the Teensy, that's of course moving along really fast. I think that's running in the order of around 60 or 70 megahertz on its processor clock. That's why you can get I/O toggle speeds of 10 megahertz. If you're looking at about 6 instruction cycles to do just these 2 lines of code over here, that'll give you 10 megahertz, and that's fast, very, very fast. So that's a simple little program that I use for testing, so you can screenshot that if you want to for your own use. It worked very well for me, and that code works in all the processors. You just tell your IDE which processor you're using, and you just comment out what you don't want to use in the test. Just remember, if you want to do any of these tests for maths, you've got to do the analog read first. So all the maths calculations included the use of an analog read in this test. Okay, so that's it. Quick little video. I'm going to end it at that and wrap it up. Something different, something nice. It's always nice to review data and have actual numbers to look at instead of wondering about these things. So, right, take care. Have a nice day further, ladies and gentlemen. See you next time for more stuff. Right, cheers.